Good morning, everybody. Hopefully you're ready for another exciting morning of chemistry with your host, me, Dr. White. Based on Friday's lecture afterward, in case you don't know, this is Kenneth 1105, and let's get started. All right, before I go into this, let me talk about a few things. First of all, tomorrow for part of you, if you registered for section 001, you have lab on Tuesday. Don't forget, you need your lab book, you need safety goggles, you need to be dressed properly, and show up. Another thing I didn't mention, which I'll go through right now, you need a calculator for our class for the test, and also when you do the labs, you don't have to bring up a lab, but you need one. This is one I've used for a long time. I tell students, Texas Instrument. I checked last night at Walmart, it's about $12. Staples, same one is $16. And I have looked on Amazon. And the nice thing about it is Target has the one without the solar battery charger. I get this with the solar because that way you don't have to worry about during the test, oh no, my battery died, which is not a good thing. And I'll teach you later on this semester how to use the calculator. This will be using it. All right, I was talking last Friday about physical and chemical changes. And physical change, I think I had talked about this, but it's good to back up. Oh, one other very important announcement. If you go to my YouTube channel, you'll see I have last week's lectures already on there, because beginning of last semester, it took me a while to get the camera, and the lectures I'm missing, I'm doing this semester. One thing about this room, the slides don't show up well on the screen, but you've got copies of it. And notice I'm a YouTube star. And so is the back of your heads. But anyways, those are available. Try and keep up. Just for your information, to process the video takes about a half hour. Actually, just letting the computer do the thing. Upload to YouTube, a large file like they are, takes about an hour and 20 minutes. I have fast internet. But anyways, let's get back to physical changes. There is a physical change. That's a process which a substance changes its physical appearance or its state of matter. That's another way of thinking of it. An example of that would be if I put my water bottle into my freezer at home and check tomorrow, this no longer will be a liquid, it will be a solid. You make ice, and that's a physical change. But water is still water. If I take water, put it in a pot, and boil it, it doesn't have to be water, it can be any liquid. Boiling is a change, a physical change, but you're not actually changing the material itself, the substance, and that's a physical change. Now the other type, which is more exciting, well they're both exciting, but this is more fun, and that is a chemical change. And that's where an original substance is converted to a new substance that has different composition and new chemical and physical properties. And not to scare you, but I will, in your stomach, the food you consume, and hopefully you did what my mother told me when I was about 2, chew your food before you swallow your choke, and I found out she wasn't lying to me. But anyways, when this food goes into your stomach, it undergoes a chemical change. So next time you eat, think about when, I don't want to ruin your breakfast, lunch, or dinner, but when you swallow it, goes to your stomach, it changes into other things, and that's a chemical change. Another chemical change, which you're all probably familiar with. Question?
Can you make it a little bigger, please?
Gotta talk loud because unfortunately over the weekend I did not have a miracle happen to me. My hearing still is awful.
Can you make your screen a little bigger?
A little louder, larger? Sure. Thank you for your question. Remember, I haven't said it in a while, in my class, all questions are good questions. Is that better?
Yeah, it's good.
Thank you for bringing it up. Also, it'll be easier to see it on the videotape. Also, when I write on the board, this is a high-tech whiteboard, and I can change the font like that. Ooh, it's not working today. But anyways, so if you need me to write larger too. All right, so chemical changes. Another chemical change, which you probably don't think about, is if you drove here, you or someone else drove you, when they stepped on the gas pedal, it fed more gasoline to your car engine, assuming you have a gas engine as opposed to a diesel. And even a diesel will do the similar. And that gasoline is undergoing a chemical change to move your car. So chemical changes are all around you. I think I mentioned it last week, but I'll mention it again. If you're an organic chemist, when you were younger, you were a closet pyromaniac. You like to burn things. And the next time you light a match or do light a candle, you're doing a chemical change. I don't know if I'll get the chance to talk to it, but a regular match, when you strike it on the side where it says strike here to light it, you're actually doing 3 chemical reactions or changes to make that flame. And like I said, I'm a pyromaniac at heart. No, I don't burn things anymore. But butane lighter, you know the little lighters, they're bigger ones that are red for your either barbecue or fireplace. Those, when you click it and burn the liquid in there, which is butane, it's undergoing a chemical change. And I already mentioned digesting food. And on a test, I could ask, give an example of a chemical change in your daily life, and I've just given you a couple. All right, let's move on. One of the things I try and do in this class is pretty much, even though I do later on jump around, follow the order of the book, even though you don't have to buy the book. Don't buy the book. But anyways, let's talk about temperature. Temperature is something in our daily life. If you listen to the weather forecast this morning, they told you about what's the temperature now, what's it going to go up to, what's it going to go down to, what's temperature. I'll never ask on a test what is temperature, but you should know what it is, and that's a measure of how hot or cold the substance is compared to other substances. Again, I won't ask this on a test. Those of you in the back, if everybody in front of you is witness, I said that. And same thing, another way of considering temperature, heat flows from a substance of higher temperature to a substance of lower temperature, which is why when you're taking a baking pan out of your hot oven, you're not going to do it barehanded or you'll burn yourself. This is transferring heat to your hand and damaging your hand. I had a student in organic chemistry came in, his hand was all bad. So I said, what'd you do to your hand? Well, I took a cookie tray out of the oven without a lid on. And after that, every lab, I kept an eye on them. If somebody's stupid enough to do that, I don't know what they'll do in the lab. But remember, protection is good for hot things. So when we talk about temperature in our daily life, there are different scales for temperature. And the first one is Celsius, which we use mainly in science. And it's abbreviated either by degree C, DEG, letter C, or a little superscript circle and the letter C. And once in a while, the old name centigrade will pop out of my mouth because when I was a student in college, it was called centigrade. I forgot when they changed it to Celsius in honor of that great scientist. Another measure or scale of temperature is Kelvin. And Kelvin is used mainly for either very low temperatures or gases. When we get into gases later in the semester, I'll talk about Kelvin. For some reason, which I've never looked up, it's not called degrees K. This is called K or Kelvin. And it's named after Lord Kelvin, who was a British scientist who made a lot of great discoveries in gases. and it plays an important role in gases. And if you look at the temperature in outer space, they usually just record that in Kelvin. And the last one, if you've been brought up or live in the United States, you're quite familiar with, and that's Fahrenheit, which is abbreviated degree F, or the superscript circle F. And Fahrenheit is also a scale. And here in the United States, if you listen to the weather report, except in the last 10 years it's changed, sometimes I'll even tell you Celsius, but usually it's degrees F. Now, for many years I worked for two different companies that were Anglo-Dutch, mainly Dutch, so I got to Europe a lot back in the 80s and 90s, before most of you were born. That's a long time ago, but anyways, when I go, because of the level in the company, I stay there anywhere from 2 to 4 weeks in Europe, which was nice. After, by the end of the time, I was glad to get home. But even though I was in the best hotels. And when you listen to the reports, it would always be in Celsius. And being an American, I'm familiar with Fahrenheit. So what do? You do the following. You use conversions. Now, here are 3 formulas that help you convert from one scale to another. And I'll talk later on, where it's in purple, about exact numbers. But at the bottom, I'll be subtle, know how to use these. Now, about 1.5 years ago, I changed my philosophy on how I teach chemistry. And I decided I wanted to test students' knowledge of chemistry, not how good they can remember things. Because in the past, you would have to memorize these formulas. For this class, on each test and the final, I will provide attached to the test or final important information. And I'll be giving you these formulas. Let me show you in Blackboard. If you look in the lectures folder, you'll see if you scroll down to the very bottom, important information, test 1. Let me just open this up briefly. And one of the things I'll give you are those 3 formulas. This will be attached to the test 1. So you don't have to memorize them, which makes your life a lot easier. Thank you, Dr. White. You're welcome. But you do have to know how to use it, and I'll be testing your chemistry knowledge. So let's take a look at this. Everybody, can I have your attention? Everybody take a deep breath. Let it out. Take a deep breath. Let it out. You're all relaxed. Stay relaxed. We'll be doing some math in here. Stay relaxed. Any math we do in here, I'll teach you how to do it. Take a deep breath. Let it out. We'll also be doing some story problems. Relax, and I'll teach you how to do story problems. So let's take a look at the following, and let's say sometime in the future, sometime in the future on a piece of paper I might hand out in this class, on the test, I might ask the following 4 points. If the temperature outside is 54.6 degrees Celsius, what is the temperature in degrees F? By the way, if you can't read my handwriting, important question you could always ask is, what the heck did you write there? But anyways, hopefully this isn't too bad. Now, watch closely. I don't know when I developed this, but it's helped me immensely, and it's helped students immensely with, this is, relax, a story problem. And the first thing when I see a problem like this is, I've asked, what am I being asked to find, and the units. And the question here is, what are we being asked? Degrees F. So I'll write down, say right over here. You don't have to do this, but it's worked well for me and many students. How I came up with putting a question mark there, that tells me what I'm trying to find. Then I look at the stored problem and say, what am I given? And the only thing I'm given is this. Now I don't have to look at this anymore. Everything I need to solve the problem is right here. Plus, if you look at the back of important information, you will see did I get it right? Oh, I did. Look how dangerous this one, how I know this by heart. So, we're trying to find degrees F. We have this formula. We figured out that's degree C. So all I have to do is put this in. And do the math. Now, when you have something like this in this formula, you should do the multiplication first before the addition. Common mistake, students add this to this and then multiply it by 1.8, wrong, and I'll mark it wrong. But let's do the math. Now, instead of using a calculator, I'm going to be using a calculator provided by Bill Gates of Microsoft. No, I don't know him. He doesn't know me either. I'll do the multiplication first. This is the number I get. Then to that, I'll add 32. By the way, you should always keep an eye on me that I'm putting in the right numbers, and I did. And you get this number on your calculator. This week I'll teach you about what's called rounding off in significant figures. And the answer here would be I'll put down what's on the screen right now, because I haven't taught you rounding off, but I will, and it's about 130 degrees Fahrenheit, which is quite hot, because your body temperature was 94.6 or 96.4. I always get those, one of those two. But anyways, and this is how you do that. So it's important that you learn how to do these type of problems. Let's look at another one. Oh, one thing, I'm invoking now the 15-second rule or 10-second rule. After I write something on the board, a problem, give me about 10 seconds before you start writing it, so I might change my mind because I didn't do what I thought I was supposed to do. All right, let's take a look at this, and I'll decode it in case you can't read my handwriting yet. If the temperature of a glass of water is 10.5 degrees F, what is it in degrees C? Now, I like to share the fun. The first thing I'm going to ask you to do right now is figure out what are you being asked to find and what are you being given. That's all I'm asking you to do. Try that right now. I'll give you 10.7 seconds. Start. 10.2, 10.6, 10.6, time's up. All right, let's look at this. We're trying to find degree C. What are we given? The temperature in Fahrenheit. And what are you also given? A conversion formula. Now, once I have this, I don't have to look at this again. And that makes your life easier on a test. Because the more you can let, and this is something I discovered a long time ago, the more you can let paper do your thinking on a test, the better score you get. So now I don't have to reread this again. I'm trying to go to degree C, starting with degrees F. I'll use the center formula, degree C equals degrees F minus 32 divided by 1.8. And now, if I know degrees F, I can plug that in. Now, common mistake students make is they divide this by 1.8 and this by 1.8. Always do what's in the bracket first and then the division. So that way you won't get points lost. So now let's go over to our calculator. And notice the answer I get is 11.9444. I'm going to do something called rounding it off, and let's just call it, for now, minus 11.94. And you can put the rest of the fours there too. Anyways, and that's how you use the conversion formulas. And whenever I was in Europe, my favorite city in Europe is Amsterdam. If you've never been to Amsterdam, you're missing a lot. I had a saying, people ask me about Amsterdam, and I tell them, you know what it means if you're not having a good time in Amsterdam? You're dead. Oh, another wild city which I've gone to, which is when I consulted, and I still consult, is Guadalajara. That's a wild city too. Anyways, these are formulas. Let's do one more. And let's look at this one, and I'll decode it for you since you may not have gotten accustomed to my great handwriting. No, it's not too bad today. If the temperature of a gas is 101 degrees C, then what is its temperature in Kelvin? And why don't you try first, what are you being asked to find, and what are you given? And since you've already done it once, I'll give you 8.2 seconds. Start. 7.2, 8, 8.05. I got a slow clock. And let's take a look at this. What are we being asked to find? Kelvin temperature. What are we given? Celsius. what are you given in the important information in the test? And that's Kelvin equals degree C plus 273. Since I took the time to do this, well, I know what degree C is. I can just plug it in. Look out, I'm going to do the math in my head. If I make a mistake, someone correct me immediately. And we're done. And that's how you convert from different temperatures. You'll be doing this one second. I'll get your question. You'll be doing this in various things throughout the semester, so it's good to learn how to use this. In the past, I'd ask you to memorize these, but you don't have to do that. It's my special gift today to all of you. And you have a question. Don't forget, when you ask a question, I'm going to come closer, not to intimidate you, but so I can hear it better. Go ahead.
Obviously, there's the Celsius to Kelvin. Is there a formula for Fahrenheit to Kelvin?
No, you got to go through each step.
Okay.
And it's a great question. How do you go from, say, Fahrenheit to Kelvin? First, you have to convert it to centigrade, and then convert it onward, or Celsius. Did I say centigrade or Celsius? Now, guess what? That's not real world. I worked in the real world, I live in the real world, and I teach in the real world. Now, some instructors put that on the test. Like if they say the temperature is 35 degrees Fahrenheit, what's the temperature in Kelvin? Well, first you have to convert the Fahrenheit to Celsius, and then Celsius to Kelvin. I will never put that on a test or final, because that's not real world. I've never had to do that. And that's a good question. Thank you for asking that. All right, any questions on temperature? Now, if you go to Blackboard, and let's do that, you'll see under course information, recommended problem set. Have you noticed I have one for chapter 1? Let's take a quick look at this. Now you'll see some questions that you should be able to do. And notice I have certain questions. Water freezes at 0 degrees C. Is that a physical or chemical property? By the way, physical property. And if we go further on, I thought I had some on here for doing temperature. Maybe it's on the next section. I have it. If not, I'll have to add some more. Not this week, because you may not have had a chance to do it, but next week in lab, beginning of lab, I will go through problem set 1. I'd highly recommend you all do it before I go through it in the lab, and that way you'll get some practice. Remember on Wednesday I talked about the bicycle and the Blu-ray? If you didn't know how to ride a bicycle and you watched it over and over again, and the first time you get on a bicycle, what happens? You fall off until you practice and get better. This is no different. Seeing me doing a problem, well, it doesn't look that hard. But the first time you try it, it may be a little challenging, but afterward, when you practice, you get better. That way, you won't fall off on the test, which I think is a good thing, which is why my students do well in my class. Well, guess what time it is? No, it's not time to leave. I don't want that. Let's continue on to the next part. Now, for some reason, the authors put the next area in Appendix A2 and A4, which other chemistry books usually have in Chapter 2 at the beginning. So I'm going to do this now. By the way, you don't need to blow up. My slides will help. And let's talk about measuring things. And in your book, they call it measurements and problem solving. Now, I'll never ask you what a measurement is, but measurement is determination of various things like dimension, capacity, quantity, how much money do I have in my wallet besides my credit cards? That would be a measurement. Extent of something. In chemistry, we do a lot of measurements, take a lot of measurements. Now, I'll never ask you anything on this slide, but things we measure are mass, how much something is, volume. If you look in this bottle, when it was new, I refill it because I'm cheap, no. But anyways, you'll see the volume was 24.7 fluid ounces, also 700 milliliters. That's something they measure. And chemists measure volume, length, time, temperature, pressure, like the pressure in your car tire, and concentration, which is how much of something is in a solution. Other physical and chemical properties. You don't think of it as a measurement, but the next time you go in a gas station, you'll see on the pumps, octane number, and that's a measure of the type of gasoline and how it will perform in your engine. And if you have, like I have, an SUV, I use the lowest octane, but if you had, which I don't have, a Ferrari, I would use the highest octane. Well, like a Ferrari. I knew someone who had a Lamborghini coin. That was a nice truck too. All right, another thing is combustion. You can measure how well something burns. I'll teach you later a certain thing called pH, which is very important part of your blood. If the pH of your blood is too high or low, you're dead. And that's important, I would think so. And many other things chemists measure. Now, we're going to do some math here. Relax. I'll teach you how to do it. Now, when we talk about numbers, not only chemists, but all scientists use what's called scientific notation. I'll never ask you on a test what is scientific notation, but I'll expect for you to know how to use it. And we're going to go through it. All right, now, scientific notation is a system in which an ordinary decimal number is expressed as the product of a number between 1 and 10 times 10 raised to a power. An example would be some number equals somewhere 1 to 9.999, whatever, times 10 to the nth power. Now, in case you forgot or never had this, 10 to the n means n tells you how many times you multiply 10 times each other. If I have 10 squared, that equals 10 times 10, which, hopefully I did it right. If not, somebody correct me, is 100. And 10 cubed equals 10 times 10 times 10 equals 1,000. Now, what scientific notation allows us to do is take a very big number and write it concisely in scientific notation. It also allows us to take a very, very, very tiny number and write it in scientific notation. And that makes our life easier. Now, an important skill you should have, and this is something you should know how to do, is how do you convert from a decimal number to scientific notation and go back the other way? Let's find out. Let's take a simple number like this, 1,200. And the question would be, how do you write it in scientific notation? Well, here's how you do it. The decimal point in the decimal number, even if there isn't one, you assume there would be right here, is moved to the right of the first non-zero number. I'm going to assume all of you know what 0 is, and I hope you know what a non-zero number is. So if there were a decimal point, I'd move it 1, 2, 3 times to the right of the first non-zero number. and I'll write that. Any trailing zeros for now get dropped. Now, how many times did I move it? And notice I actually wrote on the board so I could see. 1, 2, 3. Hopefully you can all count up to 10 at least. And then the number of moves is n, in this case 3. So to write this in scientific notation would be 1.2 times 10 to the third. By the way, if it ever gets noisy back there or you over there, I'm not going to hear it, but if you do, feel free to close the door. Let's try another one of these. Now this is a much bigger number. And the question is, write this, and I could put 3 points, write the following in scientific notation. How do you do that? If there were a decimal point, it would be here. You want to move it to the right of the first integer. 1, 2, 3, 4, 5, 6, 7. And you drop the zeros at the end. And I get that. How many times did I move it? 7. 1, 2, 3, 4, 5, 6, 7. And that becomes your number n. And 10 to 7. Oh, by the way, I should mention, this is how I write my 7s. Back in high school, I had a German teacher from Germany. I still remember his name, Herr Brink. Herr means Mr. And he was a great teacher and a great guy. And he used to write his number like that, and I thought that was the coolest thing in the world. And ever since, that's how I write. And if you're from Europe, that's how you write a 7. And that's what I'll do on the board. On the test, I'll write it normally. All right, so the exponential term, n, is equal to the number of places the decimal point has been moved. Now, exponent, n, is positive if the number is greater than 10, which have been my examples. Let's do one where it's not. Question would be, write the following 3 points in scientific notation. Now you do the same thing. Now you have a decimal point. You move it to the right of the first integer, non-zero integer. That's this. So let's see. Here's my decimal point. 1, 2, 3, 4. 7.63. How many times did I move it? 4. Now, if the number is less than 1, then you use a negative number. So this would be times 10, but because it's less than 1, I moved it 1, 2, 3, 4. This is negative 4. See the negative number? And that tells you it's a small number. So when it's greater than 10, n is positive. When it's less than 1, n is negative. Now, when it's between 1 and 10, n is 0, but as far as I can remember, and I never will, I've never put an example like that on the test, and that doesn't make sense, because I've never used that in putting a number like that in scientific notation. I was in the book, and so I put it on my slide. Now, one of the things you'll learn this semester is Dr. White likes to share the fun, so I'm going to let you have some fun. Write that number in scientific notation. I'll let you have some fun too. Came in late, don't forget to sign in before you leave. I'll leave it here. All right, let's take a look. How do you do this? If there were a decimal point, it would be there. There's not one. So what do? This number is greater than 10. Hopefully all figured that out. And now move it to the right of the first non-zero number. And how many times? 1, 2, 3, 4, 5. Zeros at the end. When you're greater than 10, you drop. What's n? 1, 2, 3, 4, 5. And that's how you, ooh, let's do another one. These are fun. And why don't you try this one? Why don't you write this with sign in scientific notation? I see a question back there.
Are there going to be any test questions where we do the opposite? Like you give us a number in scientific
You're
notation?
ahead of me by about a minute and a
Oh,
half.
wait, never mind.
No, that's a good question. I'm glad you asked that. Now you know the answer. So the answer is yes.
Okay.
Boy, time flies when you're having fun with chemistry. Hopefully it's flying for you. Boy, it just seems like I just started this lecture. By the way, when you're done, look up and smile. Did that work? Sort of. All right. Anybody need more time? Going once, twice. Let's do this. How do we write this in scientific notation? Move the decimal point to the right of the first non-zero integer. So, 0, 0, 0. So I move it 1, 2, 3, 4. 4 times to the right of 4. Boy, I planned that. No, that just came out by accident. And then any numbers after 4 you write down. How many times did I move it? 4. This number is less than 1. So that will be minus 4. And let's just make sure I counted right. 1, 2, 3, 4. Why am I doing that? Because I'm moving the decimal point to the right of the first non-zero number. It's less than 0. And by the way, you are learning scientific notation. Now hopefully it hasn't been that painful. All right. To answer the question of one of your colleagues, let's do the opposite. If I were to ask, write the following in decimal form, convert it from scientific to decimal. How do you do that? You put down the numbers here. My decimal point was here. This is a positive number, therefore you move it to the right. In case you forgot, this is the right. And how many times do I move it? 3 times. 1, 2, oh, nothing there. When there's nothing there, you put in a 0, 3, and the number is this written in scientific notation. Help if I do the right problem. Let's look how to do this in scientific, going from scientific to decimal. Now, I'm going to write down 7, 6. If there are anything after 6, I write that down. Here's my decimal point. When this number is negative, you go to the left. That way, left hand. Oh, I got it right. No, actually it's left. Now look out, it's bad humor time. And when it's negative, you move to the left. How many times? Here it is 1. Uh-oh, no more numbers. Now I put in a 0. 2, 3. 1, 2, 3. Now, I don't know where I started this. If you write this down on a test, it's perfectly correct. But when you have a number less than 1, I always put a 0 there. And I'll do that on a test. You don't have to do it. If you do this, it's correct. If you do this, it's correct. I just like doing that, and that's just my personal preference to do that. And since you know I'm going to share, so you have some fun too. Why don't you write that number in decimal form? Don't forget, commercial from Dr. White. You can see these classes on YouTube. The link is in Blackboard. Also on Monday and Wednesdays, I don't have time after class for questions because I've got to get to Elgin, teach there. But on Tuesday, Thursday, and Friday, Tuesday and Thursday after lab, Friday after class, I'll have plenty of time if you ever have any questions. All right, let's do this. How do you write this in decimal form? Well, if you notice N, 4, is a positive number. We move the decimal point to the right. How many times? 4. So I have 3. Here's my decimal. 1, 2. Uh-oh, I need more. So I'll put in 2 more zeros. 1, 2, 3, 4. And that's how you do it. Notice I took 3.14 because that's 5. For those who've had math and trigonometry. Let's do one more. Why don't you try this one? Write that in decimal form. If you ever have any problems with anything I'm doing in class or the problems themselves, feel free to ask me after lab or on Friday for any help. Or if I get here early on Monday and Wednesday, which I try to, ask me then too. Remember, in my class, in my world, there's no such thing as a dumb question. All right, looks like everybody's done. I better hurry up. This is a negative number. Hold on, I'm not done yet. Move it 4 times to the left. 1. Ooh, I need some zeros. 2, 3, 4. I like putting a 0 there. You don't have to. How am I doing on time? All right, I'm going to be nice. I'm going to let you out a whole 22 seconds early. Don't tell